Hi everyone, my name is Sakshi Halkude. Today's my topic is digital storage oscilloscope. This definition is the digital storage oscilloscope is defined as the oscilloscope which stores and analyzes the signal digitally, that is in the form of 1 or 0 permeability, storing them are analog signals. The digital oscilloscope takes an input signal, store them, and then display its storage, tracking, and measurement. Also, it displays the signal visually as well as numerically. Working principle of digital storage oscilloscope. The digital oscilloscope digits the stores the input signal. This can be done by the use of circuits, cathode ray tube, and digital memory. The block diagram of the basic digital oscilloscope is shown in figure. The maximum frequency of the signal, which is measured by the signal digital oscilloscope, depends on the two factors. These factors are sampling rate and second one is nature of converter. Sampling rate. For safe analysis of input signal, the sampling therapy is used. The sampling theory states that the sampling rate of the signal must be twice as fast as the highest frequency of the input signal. The sampling rate means analog to digital converter has a fast conversion rate, and converter is the converter uses the expensive flash whose resolution decreases with the increase of the sampling rate. Because of the sampling rate of the bandwidth and resolution of the oscilloscope are limited, the need of the analog to digital signal converters can also be overcome by using the shift register. The input signals are sampled and stored in the shift register. From the shift register is the signal is slowly read out and stored in the digital form. This method reduces the cost of the converter and operates up to 100 megasample per second. The only disadvantages of the digital oscilloscope is that it does not accept the data during distribution, so it had a blind spot of the time. Waveform restrictions. For visible the final wave of the oscilloscope, use the technology of interpolarization. The interpolarization is the process of the creating new data points with the help of known variables. Data points, linear interpolation, and sinusoidal interpolarization are two processes of connecting to the pointers. The interpolarization, the lines are used to connecting the dot together. Linear interpolarization is also used for creating the pulsar and square waveform. The sine waveform, the sinusoidal interpolarization, is utilized in the oscilloscope. Applications. The applications of DSO are: it checks faculty components in circuit used in medical field, used measure capacitor, inductance, time interval between signals frequency and time period, used to observe transistors and diodes, VI characteristics, used to analyze TV waveforms, used in video and audio recording equipment, used in designing, used in research field. It is widely used an oscilloscope. Advantages and disadvantages for DSO. Advantages: portable. It has portable, have highest bandwidth. The user interface is simple, speed is high, and disadvantages of DSO are complex and high cost. CRO probes. We can connect any test circuit to an oscilloscope. The probe or CRO is a basic oscilloscope. The probe which is connected to it is also called a CRO probe. A CRO probe should have the following characteristics: high impedance and high bandwidth. Types of CRO probes. CRO probes can be classified into following two types: passive probes and active probes. Now let us discuss about these two types of probes. One have passive probes. If the probe head consists of passive elements, then it is called a passive probes. The circuit diagram passive probes shown in figure. H head consists of parallel combination of resistor R1 and a variable capacitor C1. Similarly, the termination circuit consists of a parallel combination of resistor R2 and capacitor C2. The above circuit diagram is modified in the form of bridge circuit and it is shown in figure. We can balance the bridge of adjusting value of variable capacitor C1. Consider the following balancing condition of AC bridge. This is equation of AC bridge Z1, Z4 equals to Z2 and Z3. Active probes. If the probe's head consists of active electronic components, then it is called the active probe. The block diagram of active probe is shown in figure. As shown in figure, the probe head consists of a FET source follower in cascade with BJT emitter follower. The FET source follower provides high input impedance and low output impedance, whereas the purpose of BJT emitter follower is that it avoids or eliminate the impedance mismatching. The other two parts such as coaxial cable and termination circuit remain same and both active and passive probes. Thank you.